Caroline King, and for the past few months, I've been analyzing a data set on how student athletes of Division One universities perform in the classroom. This data set was of interest to me because I currently work as a tutor at the University of Central Florida for student athletes, and so I'm able to see how a small sample of athletes performed firsthand, but this is more of a general overview from athletes across the country. So we will get into some of the results of my analysis in this data set. So the first thing we're going to start with is just some general information about the data set. So it was created by the NCAA, also known as the National Collegiate Athletic Association. This is the main association that deals with college athletes. Many of you are probably familiar with it. This data set had a sample size of 6,511, and these are not individual players. These are sports teams. Each individual sample was a team, not a player. The target variable that I was looking at is the academic progress rate score, or the APR, and we'll get into what that is in a little bit. The categorical variables that this data set included were the name of the sport, the school name, the conference, and the school type, that's in private school or public school. There were more variables. These were the ones that were most of interest to my analysis. Additionally, there were numerical variables, such as the number of athletes that were on that team, the eligibility rate for that team, the retention rate, and the year that the data was collected, or from which the data was collected. So the academic progress rate, or the APR score, is a certain score that was created by the NCAA in 2004. And this is something that's unique to this division. If you aren't familiar with the academic side of college sports, you probably haven't heard of this. And it's basically just a uniform way to measure a team's academic performance. Of course, they are students for their athletes, is something that's often brought up. And so the NCAA likes to keep track of how teams are performing. So basically, a team gets a certain number of points based on the amount of players on the team, and for academic achievements and other reasons they get points, and it's divided by the total points that they could have earned and then multiplied by 1,000, and it ranges from 0 to 1,000 because of this reason. And if you get under 930, your team is ineligible to compete for the next season, so they have a lot of motivation to keep that score above 930. So for this analysis, I had 3 goals. There was a lot I could do with this data set, so I wanted to narrow it down. The first goal is I wanted to compare academic scores by sport. The second one is creating a linear model with my response variable being the APR score, and trying to find which variable is the best predictor of this score. Lastly, we wanted to look at the difference between conferences and if any one conference is scoring significantly better than another one. So the first goal was comparing sports, and there were a lot of sports in this data set. It would have been overwhelming to look at the scores of all the sports at once on one graph. So I decided to narrow down the sports. And the way I did this was I looked up which sport brought in the most revenue for a university. This typically relates to popularity, as universities are going to put more effort into the sports that are bringing them in more money. So the top 5 were football, which I'm sure we are not surprised by that. In fact, it's significantly higher than the rest. Men's basketball, men's ice hockey, women's basketball, and baseball. And this is not a chart I created. This chart is from Business Insider. And so after looking at these 5 sports, I decided to go with football, men's basketball, and baseball. The reason I did not go with men's ice hockey is because I wanted to create a presentation that was relevant to the audience. And in this case, we live in Florida, and baseball is just more popular than men's ice hockey, as typically our weather's above freezing. Also, I decided to not include women's basketball because I wanted to control for the fact that females and males may score differently in the classroom, and I just wanted to get rid of that as a confounding variable and just stick with only men's sports. So the first thing I did was look at a histogram of these scores, and as you can see, it is skewed left, or a majority of the values are in this upper end of the histogram. I wanted to make sure that this wasn't just for these three sports, because if it was, that would be an interesting thing to note. So I went ahead and went back to all the sports, looked at the histogram, and noticed that yes, all the scores seem to be in the upper end. And if you go back, if you remember that under 930, which is about right here, a team becomes ineligible. And as these are all Division I universities, and Division I universities, most of their income and revenue, a lot of it comes in from their sports. It's a big part of who they are. So there's motivation to keep sports eligible and to keep them above 930. And so that is probably why right around there it drops off and it's a lot less teams. So after looking at that, I decided to compare the baseball, football, and men's basketball using a box plot. You can see that baseball is just ever so slightly above football and men's basketball as far as score goes. And something else to note is that baseball has less outliers as well as a smaller range. And this just means more consistently they're scoring in this upper end, while football and men's basketball have a little less consistency. Something important to note here is that all these boxes do overlap, showing that there's really not a huge significant difference between the scores of these three sports, which is interesting to note. If you thought maybe, if you had a pretension that maybe one sport would be higher than the other scores, this shows that that's not the case. So the next goal I kept with the three main sports, basketball, football, and baseball, and decided to create a linear model using the 4-year APR score as the response variable. And the NCAA tracks the APR score of a team per year, but the big one, the one that keeps the most accountable, is the 4-year score. And so that is why I chose to go with the 4-year score. So the three variables that I wanted to test to see which one was the most associated or correlated with the APR score is the number of athletes on a team, the 4-year eligibility rate, and the retention rate. And from analyzing this, I found that the eligibility rate was most closely related to the APR score. So eligibility rate is if a student athlete has below a 2.3 GPA, they are ineligible to perform. And so if you take however many players are ineligible, or how many players are eligible, and divide it by the total number of players on the team, that's how you get your eligibility rate. And considering that eligibility rate directly has to do with how a player is performing in school, it would make sense that these two variables are highly correlated. So here's the linear model that was created, and as you can see, that it is mostly focused on the upper end. Did run checks on this model, and the residuals are normally distributed, as well as the R-squared meets the benchmark for it to be considered a useful model. I did try transforming the variables to see if I could get anything more useful, and this was the model with the strongest correlation. So here we can see that it's positively correlated. So the higher the eligibility, the higher the APR score, which would make sense. The y-intercept is 376. In this case, a 0% eligibility rate probably isn't possible if all of the players on a team are ineligible. So that doesn't really have any intrinsic value. But the slope is saying that for every 1% point increase, it increases by 608. And so, or not 1 percentage point. So like by 1 whole point, it increases by 608. And then lastly, we're going to look at the conference comparison. And so the reason I wanted to look at conferences is because probably something relevant to the audience is that we go to a school in which our football team performs well, but there's controversy around how well we perform because of the conference we're in. In the football realm, there's certain conferences that are viewed as more highly competitive as other conferences. And why would this relate to academics? Why would this be important? Honestly, even in the world of academia, schools are better known by the way their football team performs. And so it really is important to a school's reputation as a whole, even when you go to job interviews and which school you go to. It a lot of times relates back to if your employer knows it, either whether they're from that area or if their football team is something to watch. So conferences that are seen as the most competitive in football are Power Five conferences, and specific things, these specific conferences, basically like have the best reputation for football and are seen as the most competitive. And I wanted to compare how this conference does academically, because we know athletically they're seen as above, but how do they do academically compared to our conference, which is the American Athletic Conference? You can see UCF, and then also threw in the Ivy League there because they're known for being academically superior, so I wanted to test that out. So I compared the Power Five conferences, American Athletic Conferences, and the Ivy League Conference. Here's what we found. So these gray conferences in the middle are all the Power Five conferences. This is the American Athletic Conference, and the pink is the Ivy League. So as you can see, Ivy League is above the rest of the conferences. The median score is above the top 25% of all the other conferences. So Ivy League does do well in keeping their reputation of performing strong academically. As far as the rest of the conferences go, there's not a significant difference, which shows that even though their football teams might be considered more competitive, when it comes to academics, everyone's kind of in the same boat. That just might be something to take note of the next time someone tries to say something about, UCF versus a different school that has a better reputation. Say, well, honestly, all the athletes perform the same academically, if you want to compare that. So today we went over a sport analysis where we compared football, men's basketball, and baseball and their scores. There's also a linear model where we found that eligibility rate is the most closely correlated with the academic progress rate score of student athletes. And then lastly, we compared conferences and found that the Power Five conferences really can't brag when it comes to academics. So thank you so much for listening to this presentation, and I hope you guys have a great day. Thank you.